In this talk, I'll be giving a short intro to message queues. Okay, so before I start with the whole concept, so since today we didn't use this concept in any of our products, going forward, this concept will be used heavily in the server side or the whole product itself. So also this concept will be heavily used in the upcoming product in the Connect. Yeah. So to start with, so firstly, let me go to the next slide. Yeah. So the main objective is firstly to learn about what is monolithic and microservice architecture. I know most of you know it, but I'll give you like just a single line of overview, and then I'll show you why do we need this message queue in simple terms, and then why not directly call an API and why to use a message queue, and then I'll tell you a real world use cases, and then we'll show you a small demo in RabbitMQ that will show why the more users of RabbitMQ than direct API calls. Okay, so firstly, as I said, most of you know what is monolithic and microservice architecture. So monolith architecture is like a single code base where everything is taken care by it. And microservice is we chunk the whole product into multiple services, and each service will be communicating with each other, and the whole product will be working together by communicating between multiple services. So the message queue concept comes during this communication process. So in a monolithic architecture, there is no two services will be communicating with each other. There will be a client and the server, which will where client will be directly calling the APIs, and then server will take care of uh, whatever request that comes from the client. But in microservice, there will be two services or more than two, like most of the cases, and each service will be communicating with each other, and uh, the product will work together. So uh, let me explain the microservice and monolithic architecture using a simple analogy. Okay, let's say we are running a restaurant. Okay, uh, let's say we there will be a customer coming in, and there will be a same guy who will take their order, take make the payment, and then prepare the food and then serve it to the customer. Okay, let's say there are four steps. Take the order, make a payment, and prepare the food, serve it to the customer, right? So when it is under monolith architecture, the analogy will be something like this. There will be a single guy doing all the four things. So when the first customer comes, uh, the person needs to take the order, ask him to pay, and then go prepare a food and then come back serve it. Okay, when this whole process is getting done, the second customer needs to wait for the first customer to finish to get their food, right? uh, Coming to the microservice architecture, imagine a restaurant with a separate billing counter, and then a separate kitchen space where a customer can go and take their food. Okay, so what happens? Customer one comes, they will go to the billing counter, gives their order and make a payment, and then he will take the a slip or a receipt, and then he will go to the kitchen counter and he will take his or her food, right? So in this case there will be two separate places, like one is the billing counter, one is a kitchen counter where the customer will get the food. So these two counters will work separately. So in the microservice architecture as well, there will be different services. Let's say let's take an example of e-commerce. Okay, whenever you place an order, let's say you go to Amazon, place an order, right? So there will be multiple things happening in the background. The first thing is to place an order, you need to make an entry in the orders table or whatever it is, you need to make an entry into database. And then the second step will be to communicate with the registered phone number or mail also. Let's say the server will send a mail, and the server will also send an SMS to your registered mobile number. And then let's say the third thing is confirmation on the app. And then the fourth thing, let's say analytics. Okay. This when it is on a monolithic architecture, all these four things needs to be done in a single API. Okay. When I place an order, first step, there will be entry into database. Second step, I will get a communication via SMS and then mail. And third step is confirmation on the app screen that I see. And then the fourth step is update the analytics in the backend. Okay. So this is all the four steps need to be done. And then if someone else who is placing an order needs to wait till my API is executed. Let's say if there is a microservice architecture in the backend, what happens is uh, first step, it will create an entry into database. And then the second step and third step, let's say communication via email and SMS, it will be in a separate service, let's say notification service. And what this API does, it will just push a communication to the separate service, notification service, and say this order is placed, notify the user, and then it will not worry about it. It will just go to the analytics and tell the analytics service, update the analytics based on what order is placed, right? And then it will just delegate the work to other services and then immediately update this customer that your order is placed. Okay, doing this will what will happen is the customer end customer will get the response faster, and the app or the web application which the customer is using will work with a less latency. It will also increase uh, uh, user experience, right? So this is I try to explain my monolithic and microservice architecture using a restaurant and example and the real use case of placing an order. Okay, so yeah, and now coming to the message queue, right? So what happened when we placed order? This server made an entry into database and then told the other service, like notification service, to notify the user, and analytics service to make some update the analytics, right? So there are two different services needs to be communicated. Now, how is this communication happening? Is where this message queue concept comes into play. Okay, so in this message queue, there will be two actors, let's say producer and consumer. Okay, what producer does, it will send a message. Okay, in and what consumer does, consumer is notification service and analytics service in our example, right? So what consumer does, it will consume the message and then do the needful thing, like notification service will send the notification and analytics service will update the analytics. Okay, so the queue, these two messages will be pushed to queue, and these services will consume it. That is why these are called consumers. Okay, once this is consumed, let's say once the notification service consumes this message, it will acknowledge back to the queue that this message is taken care. Now you can safely delete this message from the queue. Okay, so the acknowledgement part will also be taken care. Next, why use queue and why not directly call an API? Let's say, uh, why not directly call an API in the notification service and execute the code? Why to use queue in between to send this message? Okay, this is the question. Right now, why not to you call directly the API is, let's say, uh, the API that we called breaks in between. It is not able to send the notification to the customer. Then who will be responsible to take care of it or to handle the failure? Right? The queue will, if we directly call the API, it will not make a retry. Or even if there is a retry logic written by the producer, it needs to wait till the notification is sent, right? Let's say there is a producer and the notification service, okay? the producer will directly call a notification service API. Okay. What happens is this producer needs to wait till the notification service API is executed properly. Uh, let's say you can also say that I won't, this producer won't wait for the notification service API to execute. It will just delegate the work and pass on. But in that case, if the notification service fails, the notification will never be sent to the customer. If we send this message to queue and then pass it to notification service, this queue will take care of a failure and it will retry and not delete the message until it receive acknowledgement. Okay. So yeah, the real world use case is the e-commerce example that I told. When we are creating an order, we'll push a notification, make a payment, and update the analytics and all. And coming to the benefits of this message queue is indirectly the benefits of microservice architecture. We will make the system loosely coupled. Whenever we are developing something, we can directly develop and deploy in the service that we made changes in. We need not touch every service. It is easy to scale and it is more reliable. We'll have retry on case of failures, and whole communication will be done in a synchronous process, and it will have much more better performance compared to monolith architecture. Okay, so while there are different tools available in the market to use this message queue. These are some of the popular ones: RabbitMQ, Kafka, AWS SQS, Redis Queue, Azure Service Bus. So today's I will show a small demo on RabbitMQ. Uh, and yeah, so when not use this microservice architecture is when the system is so small, we don't need any scaling or something. Then when the product is so small, then we don't need to use this communication system or complex things. If it is a simple CUD application, then we don't need to use this message queue or microservice architecture. And when we need real-time synchronous responses needed between a client and the server, then we don't need to use this architecture. Okay, so I'll go to demos now, right now. Okay. So I prepared a small logic which will uh, try to send a message to a queue, and then there will be a consumer who will consume it. Okay. So this new task, I have two files. One is worker, who will consume the message that is pushed to queue, and new task file, which is creating a new message pushing into the queue. Okay, the message is nothing but some payload that needs to be given to a function call. Okay, so firstly, I'm creating a queue called task queue, and then sending a message through inline execution, inline call, and then I'll pass that body of that message, and then I'll show you the advantages. Once I run it, you will get more clarity. So worker will consume that message and then print the message and wait for 10 seconds. Let me make it 5 seconds. It will be faster. Okay. And then it will say the work is done, and then acknowledge back to the queue. Okay. So just a simple function. Okay. Uh, I have RabbitMQ running in my local. Okay. So me let me stop that. And I'm running a worker, right? Worker is nothing but a consumer who will does the work for us. And then, okay, I will run a new, uh, sorry, I will run new task, which will create some task to be pushed into queue, and then I will show you how this travels into the queue. Okay. So let's say I'm creating a task. I'm pushing this message. something like second message, third message, fourth message, and fifth message. Like I'm sending two to like five, which is four messages. Okay, I'm executing this. It says I sent four messages, and then if you go to worker, it says I received second message. I'm done with it. It will wait for 5 seconds and go to third message. Done. It will wait for 5 seconds again. Done, and it will go to fifth message and again done. So I'll show you how what happened in between, right? Okay, let me increase the worker sleep time by 10 seconds. Okay, so that it will be more visual. Let me restart a worker. Okay, so the worker is restarted. Now I am again pushing the same message, 2, 3, 4, fifth message. Okay, so all the four messages were sent. It took the second message, and then it is waiting for 10 seconds. Okay, and I just added some delay. Okay, and it waited for 10 seconds and gone to the third message. Okay, what is happening in the queue? Okay, so this let me go to queue. This is RabbitMQ dashboard in the local. So we created this queue called task queue. Okay, uh, so there are three tasks in total. Now only two tasks. So one is ready, which is the fifth one. Okay. Now it will be updated to zero and late. Yeah, see. What unacked is like unacknowledged task, which is in execution, and total is like the sum of ready task and total task. Okay, so now everything is executed. So if we go here, uh, four and five is also fifth is also done. Okay, now let me tell you the advantages here. Okay, let's say I'm sending the messages again, and I will crash the RabbitMQ, the message queue itself, or okay, or I will crash the worker first. Okay, let me crash the worker first. I'm sending the messages again. Okay, now the worker received second message. It is waiting for 10 seconds, right? But I will crash it. I will just close the terminal. Okay. Now I close the worker connection. There is no worker running. What happens is my queue, which has four messages, will still have my four messages. Okay. And number of consumers is zero here. Once I bring back the worker back to execute the task, okay, it will again read the message. See, let me refresh. See, it read the second message, so it went to unacknowledged state, and there is one consumer who is doing this, reading these messages one by one. If I create one more consumer, the consumer count will increase to uh, two, so three. Okay, so there is one more consumer, and it will get increased to two. Let me refresh. Yeah, see. So there are two consumers now who can tackle these messages. Okay, let me remove the other consumer. Let me delete. So I have only one consumer right now. Now, so the first advantage is the worker or a service crashes down, then we will still have the messages in the queue, which will stay forever and they won't be lost. Okay. Now, let's say the whole queue itself crashes. Okay. Okay, so in this terminal, I have RabbitMQ running. I will send few messages now and crash the RabbitMQ. Okay, the queue itself will collapse. Okay, let me send messages. Second, third, fourth, fifth. Okay, I'm running. Uh, all four messages sent. Okay, worker is working on the second message, and let me crash. This is a RabbitMQ terminal. I'm just closing this terminal. Okay, crashing it. Okay, RabbitMQ is closed now. Let me refresh this. Okay, so the RabbitMQ is down now, and the worker also got closed. Let me restart the worker back. Okay, it needs a RabbitMQ. We can write the logic, it works. But yeah, since I sent the message, right? Four messages I have sent, second, third, fourth, fifth, but then I crashed the queue. Okay, let me restart the queue. Okay, now the queue is restarted and I'll refresh the page. Okay, so the RabbitMQ service is up, and if you see the message that I sent were still here. Okay, what happens here is in the background, all these messages will be written into the disk. The persistent messages will be written into the disk, and once even if the whole queue crashes, the messages will exist.
But it looks like it lost one message. Probably it is okay because the
Uh,
MQ server itself dropped, correct?
it didn't lose that one message because if you see here, the second message is
Mhm.
read here and it is done. So once it is printing done, it
Oh,
is
it is done.
acknowledging back to the
I
queue.
see. I see. Okay.
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 So we sent four messages, right? Second
Hmm.
message is executed, like taken care. So it is acknowledged. Now we have three. The third message is ran here. It is
Hmm.
waiting for 10 seconds and it is done. But it tried to acknowledge back to the queue and the
Hmm.
queue is not even existing, right? Queue crashed.
Hmm.
So then it gave the error and the worker also crashed.
Hmm.
So here we can keep a retry logic for acknowledging. And what will happen is it will keep on retrying till the queue comes back to life.
Yep. Makes sense.
Yeah. So now all these three messages will be taken care one by one. Uh, I'm sorry, worker is still down. Let me bring back the worker up. See, the third message, which it didn't acknowledge, came back again for execution. And then, yeah, the fifth message comes in, and all the three will be taken care here. So So the conclusion of this is instead of a direct API call, when we are communicating between two services, if we make a direct API call, uh, we don't know what system crashes at what time, right? So there will be no reliability. If we start using queues, we will never miss a request, and we can build a reliable system uh, with even with a scalability. It is easy to even scale using messages and queues. Any other questions?
Very important and useful information, Pranav, actually. Thanks for the session.
Yeah.